Hi everyone, we're going to work on CIA review. I'm going to work on some of the questions for you. The first one, f of x is given x plus 1 and g of x is given x squared minus 4. We want to find f of g of 3. So the first thing that we need to find is g of 3, because the value of g of 3 is going to replace the x for f here. So I'm going to keep the f outside and I'm going to find what is g of 3. So on g, replace the x with 3. So this will be 3 squared minus 4. 3 squared minus 4. 3 squared is 9. 9 minus 4 is 5. So I need to find f of 5 now. So the value of g of 3 is replacing the x on f of x. The formula for f of x is x plus 1, but instead of x, I replace 5. 5 plus 1, that's equal to 6. So that's the answer to this question. Next one, we want to find f of g of x. So this time we don't have a value for x. We just want to find the general formula for f of g of x. So again, the function which is inside should be used first. So I'm going to write the f here, and g of x, formula for that, I'm just going to copy that here. So g of x is going to replace the x for f of x. What was the formula for f of x? It was supposed to be x plus 1, but what is my new x? It's x squared minus 4. Now I can simplify this. Negative 4 and 1, combine them with negative 3, and x squared is just going to come here. And this is the answer. Now let's find g of f of x this time. So this time, f of x is going to replace the x for g. Just put the formula for f of x inside that. G of x was supposed to be x squared minus 4, but instead of that x, I'm going to replace the formula for f, which was x plus 1. So this is basically the answer. However, we want to simplify that. X plus 1 squared is x plus 1 times itself. And I have a minus 4 here. Distribute x times x is x squared, x times 1 is x, 1 times x is x, and 1 times 1 is 1. And I have a negative 4 here. Now combine the like terms. X and x are like terms. 1 and negative 4 are like terms. So we have x squared plus x is 2x. 1 minus 4 is negative 3. So this is the answer. I'm going to leave this one for you to practice. Now let's go here. We want to find the inverse function. So on this example, I have f of x equal to x minus 5 over 2. First of all, we know that f of x is basically the same as y. I'm just going to write y instead of f of x first. Now, the first step to find the inverse is switch x and y. So wherever you have x, replace with y. Wherever you have y, replace with x. So here that I have y, I'm just going to write x instead of that. And here I have x, I write y, minus 5 over 2. Now, the next step is solve for y. So I need to get rid of the negative 5 and 2. We know that we need to get rid of the 2 first because this is outside. So multiply by 2. This was division. The opposite of that is multiple. So you multiply by 2, the 2's cancel. Here I have 2x equal to y minus 5. Now undo negative 5. Add 5 to both sides. And I'm going to write the y on the left side. And the other part is 2x plus 5. This is my answer. However, I'm going to write with the correct notation. Y is f negative 1 of x equal to 2x plus 5. That's our. You can work on this one on your own. Let's go to the next one. So we want to see if these two statements are true or false. If f of x and g of x are inverses, then it is true that f of g equal to g of f and is equal to x. Yes, that is true. We learned before that if you want to prove two functions are inverses, they should be commutative. That means f of g should be g of f equal to x. So this one is true. If f of x and g of x are inverses, then their graphs are symmetric across the y-axis. Well, they are symmetric, but not across the y-axis. That's across, I'm sorry, not across the y-axis, x-axis, but across the y equal to x. We learned before that if we have, let's say, this is my function, f of x, the inverse of that is symmetry to y equal to x. This is y equal to x, and the symmetry of that is going to be something like that. You see, they are mirror of each other with respect to y equal to x. So this is the axis of symmetry, not x-axis. Okay, now let's work on this problem. We have a division. We want to use synthetic division to do that. The first thing that you need to do is make sure there's no missing term. Here we have missing terms. Between x6 and x4, x to the 5 is missing. Between x4 and 2, x to the 3 is missing. Between x squared and 2, x is missing. So we're going to replace these terms, but since we don't want to change the value of the expression that we have here, we're going to add x to the 5, but with a coefficient of 0. So it's not going to change the value of this polynomial. This one we add x to the 3. This one we add x to the 1, which you don't have to write the 1. So the new expression is this: 8x to the 6 plus 0x to the 5 plus 3x to the 4 plus 0x to the 3 plus 7x squared plus 0x plus 2. Now we're going to start the division. So first you need to set the divisor equal to 0 and solve. So I'm going to write that here. X plus 2 equal to 0. Solve for x. Subtract 2 from both sides. X equal to negative 2. This is our corner number. Don't forget to write your corner number here. Now list all the coefficients down here. First one is 8, then it's 0, then we have 3, 0, 7, 0, and 2. These are all the coefficients. I'm going to erase this. Okay, now let's start the division. So we need to bring the first number down here. That's 8. I'm going to bring it down here. So this is 8. Now multiply 8 by 2. That's negative 16. Now add 0 and negative 16, which is negative 16. Multiply negative 16 by negative 2. It's 32. It's positive 32. Add these together. 3 plus 32 is 37. Multiply 37 by the corner number again. That's negative 70. Add them together. This is equal to negative 70. Negative 70 times negative 2 is positive 140. Add them. 7 plus 140 is 147. 147 times the corner number, negative 2, that's equal to negative 294. add these together. 0 plus this number is just 294 negative. Now again, multiply this by the corner number. This time it's going to be positive 588. Add that with 2, that's 590. Now it's time to write the answer. We know that the last number here is the remainder, and all the numbers here are coefficients of the quotient, the answer. The first one is coefficient of x to the 0, then coefficient of x to the 1, x to the 2, 3, 4, and 5. As you see, the highest degree of the quotient is 1 less than the degree of the original dividend. Now, I'm going to write the quotient here. I don't have a space here. I'm going to write that here. The quotient is 8 times x to the 4, x to the 5, negative 16 times x to the 4, 35 times x to the 3, minus 70 times x squared, plus 147 times x, minus 294. X to the 0, we know that anything to the power of 0 is equal to 1. So I don't have to write that, just negative 924. And the remainder is 590. We have learned before to write the remainder as 590 over the divisor, x plus 2. However, the CIA is going to be a little bit different, so it's going to ask you to write each of them separately on a box, inside a box. Okay, let's go to the next problem. This time, we're going to use the long division. So first of all, I see that there's no missing term. X to the 3, 2, 1, and the constant, there's no missing term. So I'm just going to use the polynomial here. 12x to the 3 plus 7x squared minus 5x minus 2. Okay, now we're going to divide. Divide the first term by the first term. So 12x to the 3 divided by 3x. 12 divided by 3 is 4. X to the 3 divided by x. We know the power of this is 1. Subtract the powers. 3 minus 1 is 2. So this is x squared. So I'm going to write 4x squared here. Now multiply 4x squared by these two terms in the divisor. 4x squared times 3x, 4 times 3 is 12, and x squared times x is x to the 3. If you see that you have the same term, that means you're doing this right. Then 4x squared times 1 is plus 4x squared. Now it's time to subtract them. 12x squared minus 12x squared, they cancel. 7x squared minus 4x squared is 3x squared. Now I bring the next number down, 5x. Again, we're going to repeat the same process. 3x squared divided by 3x. 3x squared divided by 3x. 3 divided by 3, cancel. X squared divided by x to the 1 is x to the power of 1. 2 minus 1 is 1, and you don't have to write that. So here, I'm going to write x. Now multiply x by 3x, that's 3x squared. X times 1 is x. Now we're going to subtract them. 3x squared minus 3x squared, cancel. Negative 5x minus x is negative 6x. Now bring the next number down, negative 2. Divide negative 6x by 3x. So we're repeating the same process again. Negative 6 divided by 3 is negative 2, and x by x cancel. So this is negative 2. Now multiply negative 2 by 3. That's negative 6x. You see, if again you got the same term, that means we're doing this right. Then negative 2 times 1, that is also negative 2. Now it's time to subtract. Negative 6x minus 6x minus negative 6x is canceling. Negative 2 minus negative 2, that also cancels. So the remainder is 0. And this is your quotient for x squared plus x minus 2. Okay, next we're going to work on this question. So we want to write a polynomial with degree 4 with a leading coefficient of 2 that has real roots at 2, negative 5, and a double root at negative 3. So we're going to find the factors that are creating these zeros. First of all, the coefficient, the leading coefficient is 2, so I'm just going to write that. And after that, I'm going to write the factors that are creating this 0. So if the 0 is at 2, at x equal to, what is the factor that created the 0? If I subtract 2 from both sides, I will have x minus 2 equal to 0. So this was the factor that we set that equal to 0, and we found this 0. So I'm just going to write x minus 2 here. Next one is negative 5. If x equal to negative 5, that's a 0. What was the factor that created that? I add 5 to both sides, so I will have x plus 5 equal to 0. So that's the factor that created that. I'm going to write that. And the next one is negative 3. X equal to negative 3. I add 3 to both sides, and x plus 3 is equal to 0. This is the factor that created this 0. However, the point is that there is a double root at negative 3. That means the factor of this one, the power of this factor should be 2. And you see, this is the power of 4, degree of 4, polynomial with degree of 4, because the power of this one is 1, this one is 1, this is 2. 2 plus 1 plus 1 is equal to 4. That's the degree of this polynomial. Okay, I want to also explain this one to you. Okay, this time we have a polynomial of degree. This is 4. There's a typo here. This is a polynomial with degree 4 with leading coefficient of negative 1. So I'm just going to write negative 1 here. And I'm going to write the factors here. 1, 0 at 1 root at 0. That means this is the root. What is the factor that created that? Itself. It's just x. So I'm just going to write x here. For x equal to 2 over 3, what was the factor? So I'm going to undo this and go backward to see what is the factor that created this root. So multiply by 3. So we will have 3x equal to 2. Then subtract by 2. We have 3x minus 2 equal to 0. This is the factor that created this root, 3x minus 2. And the last one is negative 1 over 2. X equal to negative 1 over 2. Multiply both sides by 2. You're undoing this and going backward. So we have 2x equal to negative 1. And now just add 1 to both sides. And 2x plus 1 equal to 0. So this is the factor that created this one. And notice that this one again is said that it's double root. So you have to put a power of 2. Again, the powers add up to be 4. 2 plus 1 plus 1. That's equal to 4. You don't have to write the 1 here, the coefficient -1. You can just write a negative. So you can write x times 3x minus 2 times 2x plus 1 to the power of 2. Okay, the next problem, we have a polynomial here and we want to find all the roots. We have learned before that we can factor these polynomials and then set each factor equal to 0 and solve them. However, there is an easier way that you can use it on CIA. That is just using your calculator. So I'm going to use my calculator and enter this function into my calculator. As you see, 3x squared plus 10x minus 8. I already entered that here. You just need to go to y equal and enter it. Then make sure your window is big enough to see the function. Mine is -10 to 10 for x, -20 to 10 for y min and max. Now I'm going to graph. Press this one button, and this is your graph. So it's asking us to find the roots. Roots are zeros or x-intercepts wherever your graph is crossing the x-axis. So let's see how we can find that. We go to second trace and go to 0. This is going to give you the x-intercepts, roots, or zeros of the function. So I press enter. Now it's asking us what is the left bound. The cursor is already on the left side of this 0. You see, we have 2 zeros here. One is here, one here. We're going to start finding this one. The cursor is already on the left side of this point. So I'm just going to press enter. And then what is the right bound? Move the cursor to the right side of this point. Somewhere around here, enter. Now it's asking, what is your guess? Move the cursor almost to the top of the root here, the x-intercept here. This is not the exact value. You need to press enter to get the exact value. It's 0.6. So the first root is at 0.6. Let's find the next one. For this one, again, I'm going to do second trace and go to 0, enter. And it's asking what is the left bound. Move the cursor to the left side of this 0. Enter. And then move the cursor to the right side of that. Anywhere on the right side is okay. Then move it almost to the top. Then enter. It's equal to -4. So the next 0 is equal to -4. Okay, the roots of the function are now at 0.6 and 0, because you know this is x and this is y, and -4 and 0. These are the roots of the function. Now let's go here. It's asking us to graph the function, sketch the graph of the polynomial. Well, if I have the calculator, I can just follow this and copy that here. But I could also guess that how does the graph look like, because I have the zeros now, and I know that this function is an even degree function and a positive leading coefficient. So you know that even degree function and positive leading coefficient has end behaviors similar to x squared, like the u. So the end behaviors are here. And also we just learned that the zeros of the function or the roots are at -4, 1, 2, 3, 4. -4 here and almost 0.6, which is, let's say, almost here. So I can graph my function from one end behavior. I'm going to cross this and then go to the other end. So it's here. This is the graph of my function. Okay, now it's asking us label the x and y-intercept. Well, we know that this is x-intercept. The other name for that is 0. This is also x-intercept. Where's the y-intercept? It's right here. This is the y-intercept. That's where the graph is crossing the y-axis, and we know that on the y-axis, the x value is 0. What is the y value here? I can find it from my function. So if I go to second trace and go to the value, the first one value, enter, you know that on the x-axis, on the y-axis, the x value is 0. And if I press enter, it's going to give me the y value. Of course, you could also just count these points and found that it is at -8. But anyway, this is how you can find the y-intercept as well. So that's at -8. Then it's asking us to find the end behavior of the function. Label the end behavior. So one easy way for you all to figure out what is end behavior is, first of all, label your x and y axis. If this continues moving, where does it go? It goes to infinity, positive infinity. On this side, if continue goes to left, it will go to negative infinity. On this side, this is going to positive infinity. The y-axis continues getting bigger and goes to positive infinity, and here is negative infinity. So I just first labeled my x and y axis. Now I'm going to look at the end behavior, this one over here. Where is it going? It's between positive and positive infinity. So it's going to infinity this way. I'm going to write that here. If x goes to infinity, positive infinity, that's where the x is going because it's between these two. The y is going to go to positive infinity as well. On the other hand, here, this end behavior is between negative infinity and positive. The x goes to negative infinity. So I write x goes to negative infinity. Y goes where? To the positive infinity. So that's the end behavior. I'm going to leave the next function for you to figure out the roots and graph and answer the other questions. Let's work on this question now. An even degree function must cross the x-axis at least once. We want to know if this is true or false. Well, an even degree function looks like this. It could be this way, or it could be this way. So this time it's crossing at only one point, or it could be this way. Over here, it's crossing at 2 points. But as I showed you the first time, this function is an even degree function, but it's not crossing the x-axis. So sometimes it does, sometimes it doesn't. So this is false. It's not necessarily true. Okay, let's look at the next one. An odd degree function must cross the x-axis at least once. An odd degree function, we know that the end behaviors of an odd degree function goes to two different directions, something like this. So what is the behavior of the function between them? Well, in order to reach from one end behavior to the other one, we have no other way than crossing the x-axis at least once. I could go this way, I could go this way, or different ways to go from one end behavior to other way, to other end behavior. Anyway, we have to cross at least once, so this is true. Even degree function must have an imaginary root. This is not necessarily true. Sometimes it has imaginary roots, sometimes it doesn't, so false. An odd degree function must have an imaginary root. Again, not necessarily. Sometimes has, sometimes not. An even degree function with a leading coefficient which is positive will have both ends head to infinity. Yes, this is right, because an even degree function with positive leading coefficient is similar to x squared, which is a u. So yes, the end behaviors are both going to the same direction, positive infinity. Okay, now how about this one? An odd degree function with negative coefficient. Well, we know that odd degree function with positive coefficient looks like this. It goes to two different directions. But if it's negative coefficient, it's going to be flipped over the x-axis. So this will be the end behaviors. This is how it will look like. In between, we don't know what is it, but whatever it's between, I'm just going to graph something random. Now, it says, we'll have the left end pointed to the negative infinity. Okay, what is the left end? That's this one. Is it pointed to negative infinity? No, this is pointed to positive infinity. So it's wrong. And this one, I needed to circle it. Okay, here we want to find the intervals where function f is increasing. You just need to put your pen here and move along the graph. See, where's your function going up or down? This is going down. Starting this point, the function is going up until this point. And then from here, again, it's going down. And starting this point, it goes up. So what are the intervals? You need to write only the x values. So start from 1 and goes to x of the end 3. X of a start, x of end. And here it starts from 4 and goes to infinity. However, on the CLA test, it's going to ask you to shade the interval on the number line. So I can shade that here from 1 to 3 is where I'm going to shade, but I'm going to put an open circle because, as you remember, we said that right at this point, the function is doing nothing, it's just standing here. After that, it's increasing. So the point itself is not included. There is an open circle here, basically. So I put open circle. And next one is 4 to infinity. That's this part. And here you put an open circle. You're going to do the same thing for the other questions. And here we want to find the graph of these functions. Look at the given function here. The parent function is x squared because you have a power of 2. And we know that the parent function looks like a u that is crossing from the origin. But now this is moved to right 3 and this one down 3. So the vertex which was here, now it's going to be moved right 3 and down 3 right here. And then I'm going to graph the function. We know that since there's no vertical or horizontal stretch or compression, I just go 1 right, 1 up, and 2 right, 1, 2, 3, 4 up here. And 1 left, 1 up, and 2 left, 1, 2, 3, 4 here. So this will be the graph of my function. I'm going to leave this for you, and I will do this one. If you have 2 minus x to the 3, there is a reflection over x-axis because we have a negative behind the x. And this 2 might be a little bit confusing. What if we just write negative x to the 3 plus 2? This is 3. Plus 2. You know that x plus 2 is the same as 2 plus x. So I'm going to write that here. Now this is easier to see what is happening. This is moving the function up 2. And we know that the graph of x to the 3 looks like this. It's something like this. There is an origin here. This origin is moved up 2, but also there's a reflection over x-axis. So this is going to be reflected over x-axis. Now, the side which is down is going to go up. This one which is up here will go down. So I'm going to move the center to up first, and then on this side I go up, this side I go down. How? We know that the first point is 1 and 1, because 1 to the power of 1 is, I'm sorry, 1 to the power of 3 is 1, so it's just 1 and 1. So this is one side of that, and then again on the other side 1 and 1, and this is how it looks like. This is the graph of the function. Okay, next question. A semicircle has a radius of r equal to 5x and is inscribed in a rectangle. Inscribed means it's inside the rectangle and it touches the sides of the rectangle. So that the diameter of the semicircle is the length of rectangle. Okay, so if the radius, which is this, is 5x, the diameter is 2 times 5x, so it's equal to 10. So this whole line is 10x. Okay, the whole line is 10x, which is the same as the length of the rectangle. So the length is 10x. What is the width of the rectangle? You know that if you draw a line here, this is also the radius, so it's 5x again. So this side is 5x. Okay, now we're ready to find the area of the rectangle. It's asking us to write as a function of x. All you need to do, you know that area is length times width. Multiply those two. The length is 10x, the width is 5x. Multiply them. 10 times 5 is 50. X times x is 5x squared. So this is a function of x. That's the area. You could also write that as a of x. Doesn't really matter. It's just an a. Anyway, this is the function. Then we need to find the perimeter. We know that perimeter is 2 times length plus 2 times width. Okay, so 2 times 10x plus 2 times the width, which is 5x. This is 2 times 10, 20x. This one, 2 times 5 is 10x. 20x plus 10x is 30x. So the function for the perimeter, or you can call that P of x, is equal to 30x. Okay, now next problem is this one. This might seem new for you. We have a new operation. Let's call this beta. We have seen different operations before, like plus, minus, multiple, or division. These are the symbols that we're using for operations that we have seen before. And this is just nothing, just as a new operation. What does that operation tell to us? What is the rule for operation? It says if you are somehow doing this operation on two different numbers like a and b, the rule is take the first one, the first number, multiply by 2 and add it by b. So if I have a beta b, let's call the name of this operation as beta. I just need to multiply the first number by 2 and add it by the second number. So we're going to do the same thing here to find this operation, the answer to this operation. 4 and 10. What do I do? First of all, do the inside the parentheses, which we always do inside the parentheses first. So inside the parentheses, what do I do? Take the first number, multiply by 2, and add it by the second one. So this is going to be 2 times 4 plus the second number, which is 2 times 4 is 8 plus 10 is 18. Now we need to use the same operation, this time with 3 and 18. Okay, so what is the rule? Same thing. Take the first number, multiply by 2, 2 times 3, and add that by 18. 6 plus 18, 24. I can do one more for you. The next operation is just a smiley face. So if I have a smile B, all you need to do, the rule for this operation is take the first one raised to the power of 2 and subtract by the second one. So here, I'm going to do inside the parentheses first. First one raised to the power of 2, subtract the second one. 3 squared is 9 minus 4 is 5. And now we're going to use the operation with 5 this time. So we want to do that with 5. The rule is the first number raised to the power of 2 minus the second number. That's 25 minus 5, which is equal to 20. That's it. So I'm going to leave this one for you. Just know that if you are using this operation, the first number raised to the power of 2, subtract with the square of the second one. Have a great day.